Hi, my name is Ryan Chatterson, and during this session we're going to be talking about decoupled aquaponics system design. Quick overview here. We're going to define decoupled aquaponics, talk about the pros and the cons, talk about the design criteria to design these systems, the key difference from operating a recirculating aquaponics system and a decoupled aquaponics system, and a simple approach to decoupled aquaponic nutrient management. Okay, so by definition, an aquaponics system where the fish and the plant growing systems are separated completely and operate independently from one another as two separate culture systems. So the water does not pass from the fish to the plants and return to the fish. That might be a capability that's designed into the final scheme of everything, but that's not how it's designed to be run, okay? Fish run as a recirculating aquaculture system. Hydroponic loop just runs as a hydroponic system growing plants with one-way introduction of nutrients from the fish into the hydroponic loop. Again, the RAS is treated normally, water discharged from RAS for nitrate mitigation, which is what we have to do in a normal recirculating aquaculture system. We have to mitigate nitrate and suspended solids that may start to accumulate in the water column. So we discharge the water just as we normally would, and from wastewater, and we match that discharge amount to the water usage and evaporation rate in the hydroponic growing area. Solid waste removed from the recirculating aquaculture system daily is either mineralized for use in the hydroponic plant system or discarded and sold. RAS water used to fertigate the hydroponic component. So we use the water from the recirculating aquaculture system to top off and supply nutrients to the hydroponic component. Now, if we're not using a mineralization tank, and we're just discarding our solids, then all of the water for the hydroponic side is coming directly from the RAS system, and we're topping the RAS off with fresh, clean, fresh water. Okay, if we have a mineralization system, then that water is first used to top off the hydroponic component, and any other water we may need can be pulled from the RAS system if we need more nutrients, or it can be topped off with fresh water if the nutrient load is sufficient. Hydroponic water is not returned back to the RAS, okay, we said that. And hydroponic water only leaves through plant transpiration and evaporation. That's the only way it's leaving those troughs, is through evaporation and through the plant's uptake. That's it. There's no discharge on those troughs. So the pros. You have the ability to cater to each culture system's individual needs without affecting the other culture system. So this gives us the ability to grow a wider range of fish species. We have a wider range of plant species that are available to culture. And we have the highest production levels possible will be achievable using this method. And that's because there's no compromise made. We are giving each side exactly what it needs. Some of the cons. Well, many designs rely on hydroponic fertilizers beyond the supplements that we add during base addition in a normal recirculating system to maintain a complete nutrient profile for the plants, which can complicate the process. Some will argue that it's not real aquaponics because you're not gaining the majority of your, or you're not gaining all of your main nutrients from fish feed other than the base addition, that you're actually adding fertilizers and you're cheating basically, okay? So a lot of people will argue that that's not real aquaponics. It takes some of the magic out of it, and that's not what they want. It's more complex designs mean more equipment and a more complete understanding of aquaculture and hydroponics because it's truly two systems. All right, on a smaller scale, some customers are not going to be as apt to buy from you if you explain it this way as they were to buy from you if you were to explain that, you know, the plants clean the water for the fish and the fish clean the water or produce the nutrients for the plants. You keep it real simple like that, people love the idea and they want to purchase from you. You go more complex and start talking about just using fish waste as the nutrient main source, and we add additions of other fertilizers, and you start getting into how complex it is. That's going to turn people off. It sounds more like a man-produced process than a natural process. So just keep that in mind when you're going out into the real world and actually trying to sell this. Follow recirculating aquaculture system design criteria, okay, that we've already discussed for sizing the tanks: mechanical filtration, biological filtration, chemical filtration, degassing, aeration, oxygenation, plumbing, etc. We already know how to design this, okay? You already know how to design this before I even go through this entire talk. So the recirculating aquaculture system, the fish side, you're going to design it just like we talked about in the first few sessions. That's done. No magic decoupled trick there. Well, we need to include a biofilter in the design, which we would always do in a recirculating aquaculture system design, but it's left out of some recirculating aquaponic designs like the UVI system. That's one of the advantages to the UVI system, is they were able to eliminate a biofilter and use the plant bed as the biofilter, which saves them money. Okay, but if you were to ever need to decouple the system, well, there's no biofilter for the fish, so they would die. So there's some downsides there too. We're going to include a dosing system on both the recirculating aquaculture system loop and the hydroponic loop for independent pH control and supplementation. Okay, where normally we would need one, in a decoupled scenario, we need two. We need to control the fish pH, we need to control the pH in the plant side. And we need to include an evaporative degassing column on the hydro loop if needed to balance the RAS discharge with the plant loop needs. So if you're discharging more water than the plant loop can handle, and you still need the nutrients that are coming in that water, but you can't get them into the system, we need to evaporate some of the water out of the system, out of that plant system, okay? And again, these could be built right into the end of one of your troughs. Very high, pump up to the top, let the water cascade down, and have it on a timer, or just manually plug it in when you need to evaporate a given amount of water out of the system. Okay, back to this picture, just like I mentioned during the Chatterson Farms talk, okay? Normally, recirculating, we go fish tanks through the filtration, through the biofilter, out to the beds. It wraps back around, comes back, and back to the sump. Well, when we turn that valve and we make this a decoupled system, we have this operating just as a recirculating aquaculture system. Fish tanks to filtration to biofilter, back to the sump, back to the fish tanks, okay? This is being topped off when we empty our water, our waste flow out of the solids filters. They go into the mineralization tank. The broken down water is sent to stage 2, and then out to the hydroponic troughs. One way, okay? It never returns. This line, nothing ever returns. That's a closed line, okay? So one way water goes here. If we need more water, we can open this valve and allow water in. If we need less water, where we still need the nutrients coming in, but this already has too much water in it, then we need to evaporate the water out of there. Now I'm in hot, sunny Florida. That has never been a problem, okay? We use normal aeration in the greenhouse, not oxygenation. Again, not a problem. We get more evaporation out of the water than someone would if, say, they were using a pure oxygen throughout the entire system. So I have no need for a water evaporation mechanism, but other people in other climates very well could have that need. What are the main differences in technology between recirculating and decoupled aquaponics? Well, in recirculating aquaponic systems, you're compromising temperature, feeding, nutrition, and a myriad of other things to make both the aquaculture and the hydroponic systems work together in symbiosis. And the key word here is compromise, okay? That was the design to begin with. But now that we've moved past compromise and we've moved on to what's the ultimate efficiency, that's why people are starting to look into decoupled, because we don't need to compromise. We can raise both organisms and use both products together, but we don't have to make compromises on either side. Also, you save some money in equipment as far as you may not need a biofilter in a recirculating system, even though I suggest that you include one in there. You don't need pH monitoring and dosing for each side. And using a recirculating aquaponics system takes less management. It does. There's less management involved because you're not keeping two separate loops with independent factors, independent specifications in there. The advantage to a decoupled system design is the fact that you don't make any compromises for the fish or for the plants because they're two separate systems designed to run independent of one another. It's easier to overcome challenges on either the fish or the plant side because you're not tied to the other production system. So let's say we needed, God forbid, you needed to spray a pesticide, you could do that on the plant side and not kill your fish. Vice versa, God forbid, you came down with large lesions and ulcers in one of your tanks and you needed to treat it with salt. You could isolate that one tank, treat it with salt, let everything else keep running, and then turn that back on and still have everything running great. Let's say the whole fish system came down with problems. Guess what? It's not tied to your aquaponic fish system. So you could actually treat that with salt, supplement with a hydroponic fertilizer in the aquaponic side until you got things figured out with the fish, then get everything back in order and start using fish nutrients as your nutrient source again. So it gives you options. There might not be options you want, but when it comes down to either have options or go out of business, sometimes it's better to have the options. And again, another example, bug infestation where pesticides may need to be used. We just talked about that. Nitrogen is the most abundant nutrient in our system, okay? That's hands down, that's just a fact. We can size the plant area based on the amount of feed per day and the estimated volume of wastewater produced per day from the fish system. We still use feed per day to calculate the plant growing area in a decoupled design. It's still about how much feed per day goes into the system. We want to estimate evaporative loss from growing area, and that's dependent on your planting scheme, how many plants you have, what types of plants you have, what the environment is, the temperatures, the humidity, the airflow. There's a lot of stuff that comes into play with estimating evaporative loss from the growing area. So there's some places you can look online for on how to calculate evapotranspiration in plants. But what I would say is stick to the feed rate per growing area, and it's already very, very closely matched to the actual evaporation that's going to happen in a typical greenhouse scenario. So I would go off of that and then do a little alteration on the back end, but it's much easier to just size off of the feed input, okay? Compare the evaporative loss to the RAS wastewater volume per day, and that's how you figure out exactly what you have to do. If it's perfectly matched, guess what? You don't have to do anything. If you have more wastewater coming out than you have room for it in the hydroponic area, you need to evaporate some of that water. And vice versa, if you don't have enough wastewater to fill up the hydroponic area, you're going to top it off with fresh water. If evaporation in plant area is equal to the volume of RAS removed daily, the system is decoupled and balanced. Okay, we just said that. If evaporation in plant area is more than RAS wastewater removed daily, make up the difference by adding fresh water to the hydroponic component. So if evaporation in plant area is less than the RAS wastewater removed daily, we have three options. The first is to create more evaporation by installing a dedicated evaporator in the form of a countercurrent degassing column or a trickle filter. All right, evaporate the extra water out of the hydroponic component so that the transfer of processed wastewater from the RAS is balanced to the evaporation and transpiration rate. If evaporation in plant area is less than RAS wastewater removed daily, you have three options. Sorry, I just said that again. The second option here is to discard the extra wastewater from the RAS, calculate the percent of nutrients lost in the process, and dose that amount of nutrients to the hydroponic component in the form of an organic hydroponic nutrient solution, okay? By supplementing the nutrients that were lost from discarding a percentage of the RAS wastewater, the systems are balanced. So in the first means, we evaporate water to still accept all the discharge from the RAS, and it's balanced. In our second way here, we discharge, we can't accept all the discharge from the RAS, so we say discard 20% of it. Well, that 20% of nutrients that we needed, we make up by supplementing them in the form of an organic hydroponic fertilizer. And then the third option is we can discard the extra wastewater from the RAS, calculate the percent of nutrients lost in the process, and increase the fish feed input to account for the lost nutrients. Okay, so if we're discarding 20% of our nutrients because we can't fit them into the water, then what we can do is increase our feed input to the fish system by 20%. And that way, even though we're discarding 20% of the nutrients, because we're increased by 20%, the plant side is still balanced and still getting what it needs. All right, so that's 3 different ways to solve this issue with balanced nutrients in a decoupled aquaponics system. The hardest way is to actually calculate the nutrients lost and add them back in the form of an organic fertilizer. It's very easy to either evaporate the water out or to increase your feed load. So here's a quick example. 20% of nutrients were lost dumping excess RAS water because the hydroponic loop is full and doesn't need any more water. What do we add back to the hydroponic system so that plants have adequate nutrients? Well, we could increase the feed amount by 20%. We could calculate the water volume discharged from the RAS, build a evaporator and put that on and put it on a timer for as long as you need. Or we could just calculate the nutrients lost and add that back in the form of an organic hydroponic fertilizer. Okay, and on that last note, so we take a water sample, we test it for macro and micronutrients. It's usually $60 to $200 to get that performed if you don't have a spectrophotometer or a colorimeter to do it yourself. And then we add back the correct amount of nutrients in the form of a complete hydroponic solution. So if you're not from the hydroponic field, it's not the most simple thing in the world to just throw together a hydroponic fertilizer. Okay, there are mass calculations that need to be done, and specific weights need to be used using a good digital scale that will weigh down to maybe 1/1000th of a gram, something like that. Okay, but there's a free management program online called HydroBuddy. If you Google HydroBuddy, you'll see it come up, and you need to download it, but it's a free software program to aid in the creation of hydroponic nutrient solutions, and you can basically put in what you need and it will spit out what the raw forms of minerals you need to use and what the weights are you need to mix them in. So check it out. A little hard for me to kind of explain in a few seconds, but really, really well worth the time to look at if you're going to be adding back in fertilizers to your solution. There's also a program called Smart Fertilizer that you have to buy. That's another fertilizer management program. Does very similar things to the HydroBuddy program. You can also call companies like AmHydro and other hydroponic fertilizer companies where they will sell you a customized Part A/B solutions. So you can send in a water sample, they'll test that water sample and sell you Part A/B solution to form a complete nutrient solution. So that's the most expensive yet easiest way to get it done. There are several decoupled designs out there in operation. You've got tailor-made fish farms in Australia. They raise barramundi and other crops decoupled and have been doing it for a long time. This is a long operating farm, and they're very large. Paul Vanderwerf, if you've ever heard of decoupled designs, you've probably heard his name. He's one of the people that's made it very popular with the implementation of this technology in a large scale, and he's done that in Abu Dhabi project, probably several other projects that he's working on right now, and in this project specifically they use tilapia, but he's got some exciting things going on. We've also got Continental Organics in the USA. They were growing coho salmon and other crops. Unfortunately, I heard a couple months ago that they actually went out of business. Not sure why. A lot of times this has to do with the business side of things, not whether the technology worked or not. But they're gone. So there's several other small projects scattered around the world and other fish farms around the world. Several large commercial systems under construction at this moment around the world. I'm actually involved in a very large project right now that I'm not releasing any info on at the time. So you guys will hear more about that if you keep up with me in the future. So decoupled aquaponics systems, in conclusion, are required when growing fish and plant species that do not fall within the same temperature and water quality requirements. Decoupled aquaponics systems are also preferred when you must maximize the production out of both the plant and the fish loop, at the added expense of additional equipment, additional labor, and additional monitoring, and additional expertise, okay? It's a little bit harder. There's more involved in creating two completely independent systems than in creating one recirculating system where both components are dependent on one another. Okay, and that's it for this session. Any questions, like every other week, send them in during your weekly question and answer session, and I'll be very happy to answer those for you. Thanks again, and I'll see you during the next session.